Well, hello everyone, and welcome to this SOLIDWORKS 22-minute webinar, the Goldilocks design principle, making it just right design decisions. My name is Dominic Gallegos, and I'll be your host. Now, we'd like to jump right in, and we're going to get started. We definitely have a lot to cover in this next 22 minutes. I want to introduce you to our presenter today, Ian Hogg. Ian is our product marketing manager here at SOLIDWORKS with over 20 years of experience in the computer-aided design and engineering field. And he's also been using SOLIDWORKS since going back to 1997. But if any of you have attended SOLIDWORKS World in the past, you may have seen him presenting the what's new for the upcoming release. And with that, I'll hand it over to our presenter, CAD-man, or Ian Hogg.
Thanks, Dominic. All right, thank you everyone for attending. We've got 22 minutes to get through this, so it's going to be fairly quick. Based on your polls, we're going to talk briefly about the value proposition that simulation can bring and how that can tackle some of those questions that we raised. Then we're going to look at some of the quick ways that we can utilize motion simulation, structural simulation, and flow simulation to get a better design out the door. So let's get straight into it. A group called Aberdeen did a survey last year. They do quite a lot of surveys, and they interviewed a variety of designers and engineers and polled them different things. One of the questions they asked, though, was about what challenges they faced in using hand calculations for performing their design work. And a lot of people replied by stating that, more recently, geometry is becoming complex, and so it's harder to make assumptions yet come with some hand calculation that's going to be relevant. Also, that there's a time factor associated with doing those hand calculations. As far as how that relates to simulation, they also asked the question about what benefit out of the customers did they get through performing simulation or virtual testing. And the key takeaway was that it actually helped them in meeting their project schedule, as well as shortening the development cycle for new products, and obviously improving quality as well. So I think one of the things that shows also is that, we're faced with many challenges. Obviously, increasing ergonomics and organic look to parts it makes shapes more difficult to analyze, along with the production timeline that we have to meet. And so we've got to try and come up with ways to meet these demands, yet still have a high degree of confidence that what goes out the door is going to work the first time. And also we have the pressure of making sure that we're delivering reduced costs through minimizing material and wastage. So another way to put this is that we don't want things to be too weak, too strong, too slow, too fast, too hot, or too cold. Or in other words, just right. But hand in hand with this, it's important that we have tools that are fast and simple to use, and they help us make smarter design decisions. Now, SOLIDWORKS has a lot of advanced capabilities, but the problem we face, as we talked about with shortened design times, is having the time to invest in doing more advanced analysis or in validating it to experimental work and so on. And so my focus today is going to be talking about ways in which we can utilize these tools to focus on simple solutions to help us in our design process quickly and effectively. We're going to do that by focusing on this dust removal system. And for motion and for structures, we're going to focus on this bag, dust collecting bag and release mechanism. So let's take a look at motion initially. In SOLIDWORKS, when you build up an assembly, you define mates. You already define the relationships between parts and how they move. Really what we need to do is to get some of that physical engineering data back out in terms of loads and motor torques and everything else. And this is where motion simulation really does a great job of helping us go through and flesh out our mechanism designs really quickly and effectively. We can easily size motors and actuators because we've got the physics in there to calculate the forces and torques. And then obviously with all that load information, then we can then use that for accurate input for structural analysis. And so this is really the sweet spot for doing preliminary work on your products in terms of quickly sizing components and motors or input devices. That's a very fast and efficient way of doing it. Now in this case, we're looking at the latch release mechanism for the bags. So we have a contact here between the strap and the hook, and once it gets to a certain angle, the friction gets overcome and it slips off. But you can see this is the torque curve going up. Once it starts to slide, it drops off and then goes back to zero eventually. If we take a zoom in look at that motor torque, there's a little spike negative here. That's because when it gets to the tip, the force is acting on the other side of our pivot, so it's actually trying to make it rotate faster than what the motor's rotating it through the gearbox. But the torque curve really is important because from that we can work out what gearbox we need hooked up to what motor to deliver that performance. And with the contact loads, we can then take those and do a structural analysis. So we can take the loads, apply them to the end of the hook, add a couple of pins to connect the linkage up, restrain it where the shaft is going to hold the crank and also where the bearings are, and then we get our nice stress analysis. And when we run that initially in simulation with a 30mm wide hook, factor of safety is 1.57. So, quick change to the dimensions, and we increased it to 35mm, and the factor of safety is 2, just over 2. So again, trying to focus on those initial sizings to get to where we need to as fast as possible and efficiently as possible. Now, a lot of structures contain weldments, whether it's supporting structure for manufacturing equipment or if it's primary structure in, off-road equipment. We can use weldments, and in simulation we can represent weldments very quickly and efficiently as beams, which makes it very fast to go and pick which is the ideal solution to move forward with from various concepts. And also we can size those weldments to determine what size tubing we need to meet our requirements. So in this example, we've got 3 different frame concepts to support the bag. We've got a complete cantilever, then we have a cantilever with some bracing to try and dissipate the bending moment, and then we finally have the front supports to try and take that load straight down into the base of the structure. When we run the analysis, you can see the factor of safeties clearly show us the bending moments in the first 2 cases are causing a much higher stress compared to the final design where it's basically compression loads in those vertical columns. So we're going to go forward with that design, but obviously if you've got different load conditions, maybe you've got a side load requirement as well, you can add all those in to help weigh in on picking which design you need. The second facet of this is then finding what sized weldment we need to carry that load. And this is where design studies really are a huge benefit, and they're very easy to set up. We're just modifying or driving the dimension for the weldment tube size, and it's just a matter of picking that dimension on the screen. It gets plugged in here, specifying the range. In this case, we're just doing 2 inch, 3 inches, and 4 inch size weldments with wall thicknesses of 1/4 inch and 0.375 inches. The requirements I've specified are I want a factor of safety greater than 2, and I don't want it to deflect more than 1 inch. And we could put additional constraints in there if we've got multiple studies. Could be vibration if you're really interested, or just other load conditions. We can put those requirements in there as well and get it to compare them. And then the output we get is for the different scenarios. So you can see the initial scenario, we see what we saw earlier with a factor of safety of 9. And then as it goes through the different sizes, you can see that the factor of safeties are reported as well as the weight and deflection. And so after running all those scenarios, it'll pick the best one. In this case, the 2-inch with the 0.375-inch wall thickness, which gives us factor safety 2.4, which is pretty good. But more also, look at the weight difference. We've shaved about 300 pounds off the weight, which is about 25%, so quite substantial. So again, it's just, you've got a lot of capability to very quickly go in the size and pick the best designs with SolidWorks simulation. Let's take a quick look at flow simulation as well. With flow simulation, the first benefit you get is being able to visualize what's going on. And that's something, when you can't see it with your naked eye, it's a huge plus. But on top of that, we get, again, more engineering information. We can get lift and drag. We can evaluate the pressure drop over a system, whether it's ducting or anything else like a radiator tube. We can look at what size pumps and fans we need to achieve the performance goals we have. If it's got electronic components or things that generate heat, then we can look at dissipation and make sure that things are being kept cool or warmed up sufficiently to meet our requirements as well. So for this dust collection system, we have these cyclone separators. The main one is for getting rid of the large particles. They just get spun in this vortex to the outside wall to fall down into the dust collection. And then the smaller chambers to get the lighter particles to fall down into that chamber as well. And then any remaining air just goes out through the fan to be exhausted. So the process of doing that, we really need to know what performance or what pressure drop we have across the system, and then what fan we need to meet that performance need. Now, when we go shopping for fans or pumps or anything, we get performance curves in the manufacturer's catalogs. And that's typically in the case of a static pressure drop across a range of flow rates. And so what we need to do is to find from our system, based on the pressure drop and our desired flow rate, which pump matches up to our needs. So in SolidWorks, it's pretty simple. We just specify an atmospheric pressure on our inlet, specify a volume flow rate on the outlet to the fan. Then while we're doing that, we want to measure the pressure drop as a simple equation. And then we create a parametric study, which is like a design study, where we can vary that volume flow rate. We can vary other things, but that's the goal for this case. And then monitor the pressure drop, exit velocity, and then do that over a range of volume flow rates. And then we have all of the results to generate our curve. So we have our fan data. We have our results from flow simulation, which can take a very short order for a very quick run. And then we can plot that on the pressure drop curve versus volume flow rate to identify which fan we want to go with. In this case, for example, if we pick the narrow width fan, our operation point is going to be at 45,000 cubic feet per minute with a pressure drop of about 10.6 inches in water. So again, it's really easy to go in and size things efficiently and quickly. And then we can actually take that fan curve data into flow simulation and let it drive the system, so that it can then see what the actual final performance is, incorporating that into the system to get the eventual pressure drop and actual volume flow rates, just make sure everything's correct. So that was a very quick summary of those three products. I would have liked to have had more time to talk about SolidWorks Plastics for injection molded design, because there's some really great tools in there for quickly identifying problems ahead of time, but we'll have to do that at a different session. But I think we all understand the need to have quick and easy tools to validate designs to meet our shorter time cycles that we're being pushed into. And I've shown you some of the quick things that you can do inside our product range to help you in validating your designs, to be able to quickly compare different concepts, to easily size the motors, actuators, fans, even members, as well as the ability to optimize things to save weight or to meet certain performance standards. And so with SOLIDWORKS simulation tools, we're really focusing on helping you to get your designs to that just right position. So with that, we'll pass it back to Dominic.
Great. Thanks a lot, Ian. That was a ton of great information. All right, so we have a couple more poll questions to ask real quick as we wrap this thing up. And first one is, we're interested in knowing your level of interest in SOLIDWORKS simulation software, whether it's just general browsing and interest, or maybe your company is beginning to investigate it and trying to understand more how it can be incorporated. Possibly evaluating products or even ready to purchase. Looks like a lot of the polls have been answered, and we'll move on to the next one. Last one is, would you like any further information from us, whether it's trying to find out how you can use this inside your company, or maybe it's training material or even pricing information? Give us quick feedback on that so we can move forward. All right. All right, so we'll close the polls. And Ian?
All right, and so now we want to open it up for any questions people may have. So at the bottom of the GoToMeeting window, you should see a questions region, and you can just type your questions in there, and then we'll try and answer them in the remaining time we have for the webinar. While we're waiting for some questions, I can just show you a few things about the actual model. So here's the actual model that we talked about in showcasing the different capabilities. So while we're getting questions, let's see, how do you validate simulation software? How do we know we get accurate simulation results using simulation? The questions is with regards to validating the software. We actually have a series of NAFEMS standard tests. The best way to look at it is simulation really is, it's a calculator. It's just an advanced calculator. So, you know, it's just doing mathematical operations behind the scenes. But we use these NAFEMS standard tests to verify that it's generating the correct results. But one of the things to point to is that there's a difference between accuracy and precision. You know, one of the reasons I promote doing comparison analysis is that you don't have to go to the level of doing full calibration against experimental data. If you've got the same setup and you're applying it to different design concepts, it enables you to do A/B comparisons to focus on which design to go in and go and refine in more detail. So that's really the focus of this presentation, but there is a lot of material around where we do comparisons against benchmarks for the simulation product. Do I require a premium license to use these tools? If you have an educational version, I believe all of these products are provided as part of that. I'm not 100% certain about that, but I know especially for things like Formula SAE, they have access to all of these tools to make it easy for them to perform all the different types of analysis that they need. But these are typically, commercially, they're different modules on top of SOLIDWORKS. So in SOLIDWORKS, you get a assembly-based simulation analysis, which is for statics. Then you have Simulation Professional, which supports fatigue, optimization, and natural vibration and drop test. Then you have Simulation Premium, which contains linear dynamics, nonlinear materials, linear buckling, and composite materials. And then you have SOLIDWORKS Flow Simulation, which is a separate product. Just because it's in a different discipline, we give people the ability to buy it separately versus having to keep, buy it plus everything else. And then obviously SOLIDWORKS Plastics. And there are simple versions for doing quick checks built into SolidWorks. There's Simulation Express and Flow Express, which do structural analysis and flow analysis. They're restricted in terms of some of the number of inputs you can do and the controls, but they're part of the software at all levels. Question is, so weldments are best done using beam analysis? So yes, because typically weldments are long and thin, and so they lend themselves to being represented as beams. So if you think about how, if you do a hand calculation on a beam, it's, sigma equals my on I plus the axial load. So it's sort of the simple bending moments and axial and shear forces is how you're going to work out the stress analysis. And so that's what you do with the beam element analysis. And so it gives you very good results, and so it makes it very easy for us to get large structures analyzed in very little time. So definitely. And you do have the option of still having solid parts in areas of concern. So let's say you've got a junction where you've got multiple beams coming together. You can still represent that as a solid geometry, so you can actually look at the stress through the 3D geometry and have beams for the rest of the structure. That works really well. Sorry, sidetracked answering questions, but there's all sorts of capabilities that we have in looking at results and different ways to slice and dice them. Here's the motion study for that, where we've got our bag and our release system. So you can see we have our graphs here. Here's our motor torque. Here's the contact force between the strap and one of the latches. And it's all very easy to work with. Can this be used to size a plate to ensure no bending when being machined? As far as it sounds like what the question is about is, let's say we're machining on a part and we've got a load applied by the cutter. We want to make sure that the plate doesn't deflect while that machining operation is taking place. And so that can be modeled. It takes a little bit of work to set it up, because what you've got to do is vary the load point over time, but we can do that and check the deflection as it moves through the position. So it is possible to do that, yes. So another question is, do we provide technical help when doing the analysis? The typical way that we provide our products is through local sources or resellers, because we firmly believe in having local contacts for support, so that they're immediately available to you and that they have a relationship with you. So if you have questions or problems with regards to using the products, there is immediate availability through your reseller. The other great place that's awesome for support is the forums. There's lots of experienced people, both people within SolidWorks, within the reseller channel, but also a huge number of other customers who provide assistance and feedback on the forums. And it's just forums.solidworks.com to help out in people learning how to apply things to different fields. But something that brings to mind is that My SolidWorks is another great place to look up that information, because the forums are also linked into My SolidWorks. So if you're talking on a particular topic, you can actually search it and it will give you a reference if it's been discussed in any of the forums as well. But also on My SolidWorks, it collates training material. You can search for particular themes or subjects that you're interested in and get it to filter to that content. So it really does give you a one-stop shop for any information you want in particular facets of the software or particular industries with regards to SolidWorks. So it's definitely, if you've not looked at My SolidWorks, go and take a look. Obviously, at the level of if you are on maintenance, there's quite a lot of capability in there. Even free, it gives you a lot of capability. But you get access to a bit more training when you're on maintenance. so free online training materials. All right.
So I think we're done with the questions, right? And we're done. All right. So as we wrap it up, I want to thank Ian again for doing really an awesome demonstration and offering some great insight into SOLIDWORKS. And as a reminder, everyone that's on this presentation will receive an email with directions for downloading this webinar if you want to watch it at a later time. And lastly, I wanted to thank everyone for attending, and I wish you all a good day.
Thanks, everyone. Appreciate your time.